Hello, I'm Monik. I will be solving starters contest on CodeChef, and I will be explaining what I'm doing. Assuming CodeChef will allow me to see the problems. Okay, let's start with this one then. So in problem, solve more problems. Having problems, for each one we know the time to need to solve it and how much time we need to take a break after solving it. We have a limit on how much time can we spend, and we want to solve maximum number of problems within this limit. So we solve a problem, take a break, solve a problem, take a break, and in the end take a break, solve a problem, and that's it. And that should fit into limit of k. So for all problems except one, we will spend time equal a plus b, and for last problem we will spend time equal a. So for a fixed set of problems, the last one should be the one with the biggest value of b, and then the time we will spend is sum of all a and b minus maximum of b. Okay, so I guess we want sum of a plus b minus maximum of b over chosen pairs to be at most k. Okay, let's try to sort the problems by a plus b. Then it only makes sense to choose some prefix plus maybe one problem with lowest a. Alright, so it's easy actually, we don't need to think about it like that. We need to think about it for all problems except the last one, we pay a plus b, so we just take the problems with minimum a plus b, and there will be one problem for which we pay a, and if that's not true and we want to take some other problems, it's always good to switch this one for the next one on the prefix. Yeah, we kind of we're choosing the prefix and one additional Okay, so we are choosing a set of problems, and among that set we will choose one problem that will be the last, for which we will pay A and not A plus B. So we always, after we have chosen that problem, we will always choose prefix of smallest by A plus B. So we can just try all the possibilities for the last one, for which we will pay A, and look how big a prefix we can take. You need to be careful, the chosen problem can be on the prefix too. So we need to carefully choose the largest prefix, but that shouldn't be that big of a problem. Alright, so we have A and B. We actually want to sort by A plus B, and we also need to know A for each problem. So our problems will be pairs, but not of A and B, but of A plus B and A. Then we will sort them, and then we will iterate over the last chosen problem, and we will have prefix sums for A plus B to quickly find what is sum on the prefix we can choose here. Sorted by A plus B. Now calculate prefix sums. There can be a case when nothing is solved, and this will give 0 as answer. But if there is at least one problem solved, there is the last one. So we will either the prefix either contains our problem or not. Let's just see if so if we can solve all the problems before and this one as the last one, then we are interested if we can actually solve more. And so the position will be So I want to find the first prefix sum that is strictly greater than what? Then how, it should be such a prefix sum that it is sum on this prefix, considering that the ice item, like we shouldn't actually sum it up, we should add ai second for it, then it should be greater than m. So if I'm not mistaken, I think it should be like this. So it should be strictly greater than this. So this is strictly greater, so we do p minus minus and update the answer. If we just cannot solve this problem as the last one, we don't have enough time, then we shouldn't try it. Otherwise, so now we know that this position is already bad, so we'll just find actually first bad position. And update the answer with p plus 1 because we take prefix of length p and another one. There is one. We can now finally look at the first problem. Some bitwise bullshit. Given n, just find 4 positive distinct integers such that some shit is true. I mean, n is even like small. Right. Okay. Well. Yes, like the only situation in which it is possible to do something bad is n equal to 0. Maybe I can solve it by hand, but generally, like, take some big number as d. It determines what this should be, and it should be like dx or n. then we can just make C equal to that number, and like here we can accidentally make C and D equal if n is 0. Otherwise it will be different. And now we just need to make sure that this thing is a submask of what we want to get here. And that is just done by saying that A and B are both just that number, and turn on some big bit which is different in those numbers, then their end will be just that number. Or we can just say that like D is equal to N, and then set some higher bits that will die out. Yeah, that sounds like a plan. Just a weird problem. Like there is nothing to solve. Just do any shit. So yeah, we'll say that D is equal to N, then turn on like 40th and 41st bits. In D, set C to be just equal to 40th bit, and now I want A and B to be equal to 41st bit. But they should be different, so A will be 42nd XOR 41st. And B will be 43rd XOR 41st. So now right, so end of this two is just 1 to 41st, then OR with C 40th and 41st, then XOR with D, this will die out, and the result will be what is given to us. I mean, I don't know how to check it, but it should be correct. I mean, not really. Wrong answer. Maybe. Cool. Is it like not working on the sample? I think it does. Okay, let's Reread the statement carefully. Well, at least repost. They fit in integer. Their sum also fit in integer. Sum over everything does not fit in integer, but it's long. Here. Read all A's, then read all B's. Oh, it's the other way around, right? Pref minus this one. Right, that was stupid. Problem balanced suffix. A string integer k. C is set of all characters. String is good if for every suffix the difference between the frequencies of any two characters in C does not exceed k. So for the all characters that are present in the whole string, if we go from right to left, it shouldn't happen that their frequencies are too spread, like greater than k. find whether there exists a rearrangement, which is good, and find the lexicographically smallest rearrangement. Well, if k is at least 1 and this is true for the whole string, then rearrangement exists, surely. Lexicographically smallest, well, shouldn't be hard to, right? If we want to construct something lexicographically smallest, we should just greedily make the first element as small as possible, then considering that we already done that, the second element the smallest, then considering that we already fixed the first and second, the third, and so on. Just greedily make every element in order to be as small as possible. So just calculate the frequencies for the whole string. Like, how does the rearrangement works? We just go left to right and put elements, like we have a bank of characters, and we take one from the bank and put it on the next position, and that will decrease its frequency by 1. So each time we want to take the smallest character that will not ruin our property and put it there. How can taking an element ruin our property? Well, it decreases its frequency and it can become maximum of all other frequencies minus k minus 1. So each time we should calculate maximum of frequencies and take the smallest character which frequency is strictly greater than maximum frequency minus k and greater than 0. So we have those characters left. As consists of lowercase alphabets only, so it's okay to just do each step stupidly, just trying all the letters, or just maintain frequencies, and that's it. How would I solve this problem if we had more than 26 letters, like n letters? Well, we should probably do kind of the same, but for example, we can maintain a set of all characters sorted by frequency. Then we can take maximum frequency right now and make an upper bound of maximum minus k. Oh no, but we have to take the smallest. Well, with something like 3, it's obvious, but I would not want to do such an overkill. Well, I guess we can maintain a set of possible next characters, take the minimum in z, by character, put it, decrease its frequency. If it became equal to maximum minus k, then remove it from set of options. Otherwise, don't remove it. So the issue occurs when we change maximum, because until we change the maximum, we can only remove one option each time. But when we decrease the maximum, all the characters that we still have should return. But that's okay, because we can also maintain a set of all characters that is still there, and just assign it here. This operation is slow, but it will be amortized because we remove elements only one by one. So in total it will be n log n. Yeah, that works. But here alphabet is small, so we don't care actually. So we're just calculating frequencies, calculate maximum of them. If there is an element that appears in the string, so its frequency is greater than 0, but it is smaller than maximum minus k, then just print -1. Otherwise, it's always possible. And we'll just fill in the answer. So on each iteration, we again calculate the maximum, which could have changed, and then we find the smallest character that we still have copies of, and its frequency is strictly greater than maximum minus k. We have such a character because the maximum one, for him, this surely holds, and this one also holds because we have spent less than n characters up to this point. This is not correct because I'm not decreasing f. This is correct. problem min add. Have two integers, minimum non-negative x such that n plus x has at most k distinct digits, and that's my representation. That sounds like a known problem, but sure. Okay, so minimum non-negative x means that we should find the minimum number that is at least n with this property. Let's make it like either it is equal to n or it has some suffix that is equal to corresponding suffix of n and like on I mean prefix, like the largest bits. Yeah, prefix is equal to the corresponding prefix of n, and then we have any digit. Okay, there will be first position in which it is different, and in that position it has bigger digits than n, and then it has anything. So we can split our possible numbers into segments, each segment having a form fixed prefix and any suffix. Then we can iterate over those segments in increasing order of value, and for each segment we will just try to solve a problem, check if it is possible to construct a number with at most k distinct digits, or it is not. And if it is possible, find the smallest such number. If it is not possible, then we just move on to the next segment. If it is possible, then it's the answer to the problem, because like on all the previous segments it was not possible, so this is the smallest number that is good. And for like fixed suffix and then any prefix, fixed prefix and then any suffix, sorry. Okay, that's correct. It's simple. Like if we already have more than k distinct digits, then not possible, obviously, we can only add digits. Otherwise, we can take some digit from the prefix and repeat it, so we will not have any new digits. And yeah, that's pretty much it. Like either if we can put all zeros, then it's good, and we can do it if either we had a zero on the fixed prefix, or we have strictly less than k distinct digits on the prefix, or like if that is not true, then we have exactly k distinct digits on the fixed prefix, and so we can only use those digits. Then we just take minimal one of them and just fill it in on all positions. You need to be careful to only consider numbers like kind of without leading zeros, and like, well, yeah, without leading zeros, but that shouldn't be an issue with like how I implement those type of problems, I think. Okay, so how do I implement them? So we will have this while true cycle. I have like current number n, it should be left border of my new segment. And then I want to choose the largest segment I can get, starting from n, so that it has the form I want. And that form is fixed prefix and then anything on the suffix. But that means that left border of that segment should have zeros on this suffix where everything is cool. So we just find the largest such lens. So while my last digit is 0, increase lens by 1 and remove the last digit. So now and let's also calculate the power of 10, the corresponding power of 10. It will be the length of our segment. So now I'm trying to solve the problem on this segment. And now let's say like solve on the segment that starts with x. The prefix is x, then there is a suffix of length len, which can be anything, and I want no more than k distant digits. No more than k, right? Not exactly k, at most k. Exactly k wouldn't be much harder, but whatever. So if it will return -1, then I just continue. If it is not -1, it will be the answer, but I need to print this number minus the n that was given to me. Okay, and if I continue, I should like jump to the after the end of my segment, which is done by adding this power of 10, the length of the segment, to current left border. So that's pretty much it. Except I need to write the solve function, but that's really simple. So find all the digits that I do have. Calculate the number of digits I have, built-in pop count. If it is more than k, then it's bad. If it is less than k, or I have a 0, so mask and 1 is not 0, just fill it with zeros. Okay, let's find the symbol that I will use to fill. So if p is k and well, whatever. So if p is equal to k, that means that I have to use the digit that already was present on the prefix. So while my current digit is not present, increase it. So now I want to fill my number with this digit, len times, and that is done like this. Okay, I will first submit, and yeah, I didn't explain why it works fast. So the idea is that, well, those segments that I'm splitting, like, they are defined by the first place where my digit is strictly greater than it was an n, and what is the digit. So before it will be all as an n. In this position I just choose it, and then it can be everything, so it will be like inside some segment fully, like one segment. So the at most length of the number, which is like logarithm base 10 times 10 such segments, and each of them is solved in, again, length time. So it's length squared times size of the alphabet. Such problems are like, it's usually supposed to be solved with like digit dp, and many problems that digit dp can be solved like this instead. It is a bit slower, it can be optimized, but it's much simpler. So that's why I like this method, and usually it's fine in terms of time limit. Problem divisible subarray counting. Either I will like it or I will dislike it very much. An array of length m is good if, when sorted, each number is divisible by the previous one. Okay. I have an array A, answer queries, find number of good non-empty subarrays of B, continuous subarrays. Yep. Okay. Can numbers A, B equal? Yes, they can, but also they're up to n. Interesting. I would understand like not equal. Well, maybe it's just for multitest, like they don't want to additionally write limit on sum of maximum of AI. Okay. When sorted, but that just means that for every two numbers, the bigger is divisible by smaller, right? Like when they're sorted, they will be on some positions, and like this one is divisible by this one, which is divisible by the next one, divisible by the next one, and so on. So like this one is divisible by this one for any pair. So we just want to make sure that each pair of numbers is divisible. So how would we try to calculate the opposite, like when it's bad? well, for each number, I want to know the closest to the left and to the right, such that they are not divisible by each other. Can I find them? Well, I probably can. Not sure how, but it seems doable. Suppose I know those things. So, okay, so my problem is as follows. I have an array, I have a query and in that array, and I want to calculate the number of ways to choose subsegment inside this segment, such that every pair of numbers inside that is like one is divisible by another, and to do that I find, like, for each element the closest to the left and closest to the right that are non-divisible by it. Like, you get what I'm saying. Like, this pair is bad. If two of them is inside subsegment, it is not good. And we can have like elements that go outside, and it is not like sorted or anything. Like, it can happen like this. We don't know. Yes. But suppose I have found those things, and they can even try to, like, so it can happen that, yeah, like this, but then this bad pair is not important, because if I have this bad pair, I also have this bad pair. So yeah, I can remove bad pairs that have some bad pair inside. That means that I will just have those like bad segments with pairwise different left borders and pairwise different right borders, and they, like, if they're sorted by left borders, they're also sorted by right borders. Otherwise, the longer will contain the smaller, and I can remove the longer. Suppose I found that. Now I just want to calculate something. Yeah, this looks simple. Like, this is probably a standard problem, but sure. So let's draw it as like, so left border of a segment and right border of a segment. Right border should be at least left, so everything under the diagonal is surely bad. And for every left border, some right borders are good, but then they're bad. So it's something like this. So this is all bad. And my queries are like given this square, calculate the like area under the staircase inside the square, this thing. And that should be fairly easy to do. Like, this thing is increasing, so I can find this point with some binary search, and like here I just have to like calculate. Well, I can calculate like the area up to this point and then subtract that constant triangle. And This area will split into parts, like here I'm just adding the area of this rectangle, and here I need to calculate the sum of heights of those steps, but they do not depend on the query. Well, I will calculate like sum up to like from the floor and then subtract this, and this is just pre-calculated prefix sums. Okay, cool. So after I find closest to the left and to the right numbers that are bad with this one, so like they do not divide me and vice versa. After that it's standard and easy. Cool. So how do I find those things? With some data structures and online with scan lines. It's simple, but I don't want to use heavy artillery. This seems like it shouldn't be that hard. Time limit shouldn't be hidden. 2 seconds is not that much, actually. Okay, I don't really need to do that. I only need to like find the shape of that thing. So like for each left border, find the closest right border so that on the segment between them there are two numbers that are not divisible by each other. Yeah, that is not that hard. For fixed left border, well, suppose we move to the right and maintain like if this property holds. If we encounter a number that was already present, then, well, it cannot break now. And if it does break, that means that it is a new number and it is like the first occurrence of this number to the right of our left border. And what I want to say is that there can't be too many of those numbers. Like if we have k different numbers such that for any pair the bigger one is divisible by the smaller one, then like each time we multiply by 2, so we cannot have more than log c of such numbers. So let's just, we'll do scan line, we move left border from right to left, so we add a new number each time, and we will maintain the leftmost position for each number we encounter, and we will maintain those numbers sorted by their left position, by the, like leftmost encounter up to this point, but we only need to store like 30 of them, such as leftmost, and then like for each left border, if we have those 30, just find the first one which is bad with someone that occurred before him, just stupidly, like in time proportional to square of them, which is just 30 squared. Alright, and 30 is actually like log of limitation, so it's n, so it's actually like 18 in this case, and well, it looks like I solved the problem that is like harder. The solution is better than the supposed one, probably because like I would be okay if AIs were like up to 10 to the 9th. It will be just n log squared, where log is log of limitation on the numbers. Great. And when I do that, then the query is everything. Okay, that I am okay to write. I mean, I was okay to write the scan line with segment 3 and asking between divisors, but no, like this is much simpler. Alright, so we need to pre-calculate something and then answer queries. So there is pre-calc, and then for queries it's, well, it's very simple, we can just write. So I want to find, I will actually just rewrite array A. I will not need it anymore. Like after I add new element, everything that's that I need will be stored in this array B of 20 leftmost unique numbers up to this point. So in array A, I will write down for each left border the right border starting from which it is bad, and so like that's my stair figure here. That's my query. I want to find the first point when it is at least R, so like all the points that are inside the square are fine. That is just lower bound. So A of P is at least R, but a of p minus 1 is strictly less than r. Assert that it is at most r. So from L to P not inclusive, I want to calculate area like under the stair, and from P to R I want to just take the whole square. So I'm calling ans 0. And now subtract like the area under the diagonal. What should it be? Something like this. Minus. It may be like wrong by r minus l in any site. Like I was not careful about like what's included and what's not, but we'll see it in sample. So like it's faster to just well, it's not like a very good way to do it, but I believe in myself, and so like I'm just saying that it is faster than actually figuring out all the plus minus ones, and I believe that I can write it correctly up to those plus minus ones, and like if the output to sample will be like fixable by adding or subtracting like r minus l for each query at the same time, then I believe that like everything is correct except this place, and it's okay to just fix it like that. It is not great in general. And it depends on like the strengths of samples. But whatever. So yeah, I'm doing scanline from right to left, adding this new element. I want to try and find it in B. If I did find it, then I will update its leftmost occurrence to be I, and now I should move it to front. Otherwise, I need to create this new element as the leftmost one and shift all the existing ones to the right. And if I already have like, this big K number of elements, then I need to forget about the last one. This is not great. It should have worked fine, but let's not play that game. So now I don't care about AI anymore. I will say that starting from right border that does not exist, it's bad, but maybe it's bad before that. So I want to check if x and y are not divisible one by another. So if, like, after the swap, x is greater than y. If it is not divisible, then I should just say that when I encounter this element, it's already bad. So if my right border is here, it's bad. Consistency, that should be right. And just calculate prefix sums of those right borders. This is not good. Is it just like all the subsegments are considered good here? Yeah, that's not right, surely. That also can be right. What is this break? I don't want it. Okay, so this is bad. This is bad. This is good, but this is bad. Yeah, 2 and 3 are not divisible by each other. Cool. Good, but it's 3, 4, 5, 6. Yeah, right. Good, but 8. But good. Okay, yeah, that looks correct. For some definition of bad and good. Oh, it's the right answer. So what what I'm waiting for? Let's just submit it. That's not what I wanted to do. I wanted to submit. And the last problem for today, yet another sort 2. Have an array. Perform the following operation. Log times n times, I assume. Oh no, the a is a big. Well, maybe log n times. Select two indices and set both to their XOR. Goal is to make the final array sorted in non-decreasing order. Alright, so we have an array. We want to get some sorted array. It is not like sorting because we change the values. We cannot choose equal elements. Interesting. So we can choose two not equal elements and set both to their XOR. Okay. Wrong answer. Wrong answer. Ref is long, cast long here, cast long here, answer is long, print long. Interesting. You know. Okay, let's just read it again. Yeah, I guess I should assert. Like, it can be all good, and I can take P to the left of L, which is not great. So yeah, let's do this. Yeah, that was it looks like a bug for real. Interesting. Not clear what to do at all. Okay, if we could take equal elements, it would probably be too easy. We can just make two elements to be zeros in two operations. Like, take them and take them again. we take some power of two elements, we can make them equal, right? If the power of 2 is 1, it's obvious, otherwise split in half, take both halves, make them equal inside, like if the numbers are equal, then we are done, otherwise match them pairwise and make them equal. That actually takes exactly like n log n operations. Okay, cool. What's next? can't be right. Is it like counting down only when I'm on the page? It's not very useful. It reminds me of the first problem. I did something hard there. But the intended solution was, it was also like merging some powers of 2. I think. And the intended solution was to like merge prefix of length to the power of 2, to of length power of 2 that fits maximum 1, and then suffix, and then either it's already good or something. Yeah, we can try to do the same here, right? Merge prefix of length power of 2 to be the same number, then suffix. Now this suffix is equal, and the rest of the prefix that we didn't touch also good. They're also equal, but they can be compared incorrectly. So what do we do then? We have some x's, and then we have some y's. Roll 2 to the power of k, and here strictly smaller. If x is at most y, then we are good. What if x is greater than y? What about their XOR? If it is smaller than y, we can just XOR like that, and we will have like 2l times x XOR y, and then the remaining of y's. What if it's bigger? Which is possible. try to swap them somehow. If we have x, x, y, y, we can get x XOR y, x XOR y, y. Then XOR this pair it will be y, y, and XOR this pair it will be x, x. Great, so I can swap two pairs of equal values. So if L is even, we should be okay. If L is not even, I can take this pair, XOR them, and then I will get just like L minus 1 times, then let's say that x XOR y is z, z, some number of y's, and then the remaining x's. So this is L minus 1, and this should be like 2 to the power of k minus L, which is more than 0, and it should be odd. So what do I want now? These pairs shouldn't be neighbors actually. Maybe if we have 3 x's and 3 y's, we can swap pairs. Okay, so I can swap triplets actually, like swap this pair and this pair, we'll get this, then swap this pair and this pair, I will get this, and then like swap those x's with those y's. Okay, that should be enough. So I get to this point, and then I want to swap this thing with like the corresponding suffix here, and I can do it if I can split this length into 2s and 3s, which is possible always except when it's 1, but then I can just like XOR x and y here and get 2, which will work for everything except n equal to 3. Can n be equal to 3? Oh my fucking god. Okay, how to solve n equal to 3? Like, I should be able to write brute force. It can be proven that the solution always exists. Not clear to me at all, but I can write brute force, for example. Let's say I have xxy and they're in incorrect order. How to make it right? No idea, to be honest. X, Z, Y, Z, Y, X. Okay. So I can actually, like, if I have two equal and one different, I can swap one of the equals with this different, like this. So XOR this two, then this two, and then this two again. Well, it's similar to like swap two numbers with XOR. Who would have guessed? But it's interesting that like all three variables behave like they should. Did not expect that at all. Okay, and the number of operations I need to do this amazing stuff is well, clearly linear here, and it shouldn't be even like a big linear, right? 1, 2, 3. 3 here and 3 here. Okay, so it's like it's less than n even. So I need to move L of them to suffix, so it will be L over 2 times 3 plus maybe another 3 to move one of them. 3 and L over 2 is less than n. L is less than n over 2. So it's like n over 4, let's say round it up even, like multiplied by 3, so it's less than n. Decent. And to make 2 to the power of k equals things, I don't really need this. Okay, so for 2 to the power of 0, 0 operations, 2 to the power of 1, 1, 2 to the power of k plus 1, it's 2 times smaller one plus source to merge them, so it's like t of 2 to the k plus 1 is t of k plus 2 to the power of k, so it's 0, 1, 3, should be 4. 2 times this plus this and 4. Then 2 times this 4 plus 12. Yeah. 2 times 12 plus 8, 32. 18, and so on. So it's like so what's the form? I would expect it to be something like this. Is it true? Minus 1, I guess. So 80 is 16 times 5. This is 5. This is 16. And if we, it's 2 times this should be. If we actually substitute here, 2 times 2 to the power of k minus 1, we get 2 to the power of k, plus this one, it's k plus 1 times 2 to the power of k, which is what we want. So yeah, 2 to the, so time to make 2 to the power of k elements to be equal, number of iterations is this. So it's like log times n over 2. Then we do it twice, so it's log times n, and then we add another linear thing. Yeah, that works. Okay, that's a nice constructive problem. Yeah, it borrows heavily from that Califorce's problem. But that's not a bad thing. it shouldn't be hard to implement, but I need to be careful to not make operation on two equal numbers. So like I need to wrap everything nicely in ifs. So I will write functions that will make the given segment of length 2 to the power of k all equal. Now if the first element is at most the last one, then it's already sorted. That includes the case when L is like n is the power of 2, so L is just equal to n. So we'll just make equal twice at the same segment, but this one actually will not do any operations. But doesn't matter. So yeah, then those elements are equal and it's fine. So if that's true, then I just need to call print ans. Otherwise, I need to swap this and this. Okay, so my swap 0 and minus L. So like swap this segment of equal elements with this segment of equal elements, and then print ans. Okay, let's do it like that. Then I don't have to actually write print ons because I call it only once here, so I can just print. We can check that it's actually sorted. Check that we have done less than allowed number of operations. So if I have only one element, it's great. Otherwise, I will split it in two, call make equal from left and right parts. If they're already equal, then do nothing. Otherwise, do the operations to make them equal. they should not be equal. Put this operation in answer and actually do the operation. Okay. Let's assort some stuff. So we want to take two segments of equal elements. The lengths of those segments should be the same. And well, we call it only here, only if we actually need to do the swap, so let's assert that they are actually equal, not equal. Assert that the length is greater than 0. And we actually know that there is an element between those segments, and if we take the element to the left of the right of the right segment, so assert that there is an element and assert that it is equal to all the elements on the segment. And if the length of this segment is odd, I will need to swap one on one, but to do that I need an additional element on either side, but I can be sure only about the existence of this one. Like those lengths can be 1, but this element outside exists. So like swap 1. That 1 is on this position and 2 others are this 2, and I should swap this position and this position. Well, it's not exactly like the set of asserts I want, but something. Okay, but now I can just swap pairs, that's easy. So while I haven't swapped everything, like now, after I did this, I know that there is even number of them. I will take 2 pairs on both sides and do the operations. So let's make op L1, L2, make op L1, L1 plus 1, and make op L2, L2 plus 1, and forget about these pairs. And we are done. here I actually have to increase L2. Let's swap 1. So here our plan was like this, but it's inversed, unfortunately. So I swap, I make the operation on x and y, then y and z, and then x and y again. And after that, a of x should be b, a of y still b, but a of z a. Well, that's weird. Oh, I just don't print /n here and it looks weird. It actually says like make operation on this two and this two. Do I really have to calculate XOR of those numbers? So that's 32 plus 2, and that's 32 plus 8, so it's 10, 10. And here also 10, 10, I guess. Yeah. What a great sample. I mean, I don't want to think about it more than I already did. Yay, correct answer. Alright, thanks for watching. Bye.